Welcome back to the Sedona Community Office Hour of June 2025. My name is Jeff. I'm the PMC chair of Apache Sedona. Happy to see you again. So, first thing first, let me just again introduce Sedona a little bit. So, Sedona is an open source cluster computing engine for processing large-scale geospatial data. And you probably have been using Sedona for some time, using Sedona in different environment. So you can actually find Sedona on our website, sedona.apache.org. We also have our GitHub account under the Apache organization. We also have a account on X. Also, we have another social media account on LinkedIn. So please be sure to follow us on these social media accounts because we post news and small tips and updates about Sedona and about geospatial big data everywhere as well. So if you're interested, be sure to follow us. So the status of Sedona. So Sedona is a project we started in 2015. It became mature in 2017, and eventually it joined the Apache Software Foundation and in 2020 and became the top level project in ASF. And it has more than 10,000 users use Sedona in production. And right now it has 138 GitHub contributors and over 2,000 GitHub stars. And each month it receives over 2 million downloads. And there are 48 million total downloads of Sedona. So this has placed Sedona among the top 0.3% most downloaded package on PyPy. As you can see on your right-hand side, so there are many companies using Sedona in production, like Amazon, GP Hunt, Mercedes-Benz, so on and so forth. Again, here is a overview about the system architecture of Sedona. So as you can see from your right-hand side, so Sedona has multiple layers. So the very first layer is the spatial query processing layer. So spatial query processing layer has integration with multiple developer tools in the ecosystem that includes Apache Zeppelin, Tableau, Jupyter Notebook, GeoPandas, and RStudio. It also offers different language bindings, including Scala, Java, Spatial SQL, Python, and R. And it also equips with a number of different query algorithms that takes spatial SQL queries and distribute the workload to hundreds of machines in the cluster. It also has a spatial query optimizer, which means it can take a spatial SQL query, understand it, and figure out the best query plan and query algorithm for this particular spatial SQL query. The second layer is we call distributed spatial dataset layer. So what it does is it decides the spatial data layout in the cluster. Basically, it partitions data across machines, and it also builds spatial indices on each partition of the dataset to speed up the query processing. It also have good spatial statistics and spatial data serialization, right? So it has really good spatial data layout. Sedona runs on top of a number of different compute engines that includes Apache Spark for batch processing, Apache Flink for streaming data processing, and Snowflake as well. And by far, our support on Apache Spark is the most comprehensive one. And on Snowflake, we also have a marketplace app called Sedona Snow. If you're interested on Snowflake, you can try it out by installing that app. And Sedona can work with a number of different spatial formats that includes shapefile, GeoJSON, WKT, WKV, Parquet, and also lots of raster formats, including GeoTIFF, HDF, so on and so forth. So the easiest way to get started with Sedona is always to use our Docker image. So we have an official Sedona GitHub, Sedona Docker Hub account on Docker Hub, and there is an Apache organization. You can find us there, and you can use this command docker pull to pull the latest release from Sedona, and then you can use docker run to run this image. So this will give you a Jupyter notebook interface that you can use Sedona's Python and SQL interface in that notebook, and also you can have visualization capability. And in our latest release, we also added the support for Zeppelin notebook in the Docker image. So you can also use another command to run the Docker image with the Zeppelin notebook enabled. Right. So regarding the releases of Sedona, as you probably already know, Sedona follows the 3-month release cadence. So we have made a couple release past year. And this year we made one release in March, so which is 171. And we are working on new release 172 right now. So we are right now doing some tests on the 172 release. So hopefully it's going to be out this week. So please stay tuned. And after the 172 release, very soon we might have another release called 180. So 180 is a major release, has some breaking changes. So we are not sure the exact time of that one, but please stay tuned. So now let's talk about what was released in our last release, 171. So that was released in March this year. So a couple exciting features were released that includes the SQL interface of our geospatial statistics toolbox. So include dbScan, getIsOrg for spatial hotspot analysis, and the local outlier that is used for outlier detection. You can call all these functions through our spatial SQL interface, stdbScan or stgetIsOrg. So if you're interested, you can find it on Sedona's website. And we also added support for broadcast k-nearest neighbor join, so that you can have better k-nearest neighbor join performance if one side of your k-nearest neighbor join dataset is really small. And the third one is a stack catalog reader. So the stack catalog reader that accurately enables you to read raster dataset that are hosted on stack catalog. So stack catalog is a common technology, a common service that is used by many data providers, raster data providers, to publish and share their raster data. So Sedona stack catalog reader is able to read a stack catalog endpoint, like HTTP endpoint, and fetch those raster images and the URLs directly. And another very important feature in 171 is OSM PBF Reader. So I'm going to talk about that later. And a couple other functions. Another one is the spatial partition data frame for GeoParquet files. So if you guys have been using GeoParquet files, as you guys probably already know, one critical factor to the performance is the spatial partitioning. So that actually depends on how you store data in GeoParquet file and make sure that the bounding box of each GeoParquet file is really tight, such that when you have a filter pushed down on those files, you can have really good data pruning performance. So that means if you have a super large spatial data set, you can save it. If you want to save it in 10 GeoParquet files, you want to make sure the data is so each GeoParquet file has very tight bounding box, right? So in our 171 release, we released a method that helps you to generate those GeoParquet files for a super large spatial data set. You can have very tight bounding box on each GeoParquet file, and also each GeoParquet file could have similar size to achieve load balance. Another cool function we introduced in 171 was the GeoArrow to Sedona data frame connector. So basically, this allows you to import GeoArrow dataset and export GeoArrow dataset. So this basically what this gives you is better performance for data importing and exporting. Now you're able to have better data loading speed when you try to load data from GeoPandas because we use GeoArrow in between to speed up the data processing and avoid unnecessary data serialization overhead. Uh, Here is a little bit more introduction about the OpenStreetMap PBF Reader in open source on the last release. So many of you probably have been using OSM data or at least heard of OSM data, right? So OSM data is probably the largest open road network data set out there. It released the road network of the entire planet, and it has the updated version of the road network published every day. And the dataset is released in this format called PBF format. It is a protobuf format. It is compressed. In order to read those files in the past, those files could be really large, right? It could be easily go over 100 gig. It makes data loading really hard. So in this release, Sedona is able to add the OSM PBF reader. That means Sedona can read PBF file out of the box directly from your S3 storage or your local disk without you actually like downloading the PBF files. And it is also really efficient. It does not go out of memory. So the PBF file, as you may know, it follows the PBF and OSM file. They follow this structure called NWR relationship, nodes, weights, and relations, right? So you can actually read OSM PBF data using Sedona format called OSM PBF. You can give the path. It will be able to load the three tables like this one. And if you want to have some filter push down, it can also do that. So it will be able to only read data that fall inside uh, the specified spatial filter. Uh, cool. So this is the PBF reader. Now let's move on. So as I mentioned, so we are working on this upcoming release, Sedona 172. Like this release will be out this week. We are working on a few final things to get it ready. So this 172 release gonna be our final release on Java 8. And after that, we're gonna release Sedona in Java 11. So if your platform has some has specific requirement of Java versions, be sure to check it out. But I believe right now most of the cloud hosting service already offer Java 11 hosting service by default. So I don't think this will be a big interruption to the product environment you have. And this release is going to be a bug fix release only. We will not introduce any new features to this release. It will only fix bugs. Another upcoming release is the Sedona 180 release. So I expect this to be out sometime like next month or the month after next month. So we are looking for a few important things in this release. So the first thing is of course, Java 11 support, right? Our code base and the compiled jar will be compiled against Java 11. And another important thing is Spark 4.0 support. As you know, I think last week Spark just announced their 4.0 release. So that's a major release and has lots of exciting features, but of course, lots of internal changes. So Sedona, as you know, it is not just an extension, it's deeply integrated into the Spark ecosystem and query engine, such that it needs to have a significant change in order to be adapted to Spark 4.0. But the good news is the community has started its effort. So if you go to the Sedona website, GitHub repository right now, so there is already a PR that works on the Spark 4.0 support. It is a big change, right? But we are working on that, don't worry. So we expect that to be done in a few weeks. so we can make new release for Spark 4.0. Another big thing for the next release of Sedona is the PyFlink support. As you know, Sedona has been supporting Flink for a very long time, but in the past, the support is mostly about the spatial SQL and in particular Java support, right? So recently, the Flink community has been working hard on their Python support as well. So they released their Python binding called PyFlink, so that allows user to run SQL query in Python environment or Python runtime. And so in Sedona community, we decided to also add corresponding support in Sedona to bring Sedona to the Python world for Flink. So we already added the PyFlink support uh, from Sedona. So this PR actually has been merged, but we are looking for the next release, next major release to release it to production. So this PyFlink support uh, also bringing significant change in our Python binding structure. So our Python binding structure, our Python binding was originally mainly focusing on the Spark side, such that so many of the code structure does not differentiate the Spark code structure and the Flink code structure. So this PyFlink support actually make our Python binding support both Flink and Spark in the same code base, but depending on the situation, you can install Flink support or Spark support within the same package. So that that of course introduce lots of changes, and I would expect some bugs once we release that. So that's a big change. Cool. Let's move on. And as I mentioned, so we won't support Java 11 in the next release, but why? Why do we want to do that, right? So the biggest reason is to upgrade to Java 11 enables us to use the latest version of lots of dependencies. So there is a long overdue issue in our community is about the raster dependency. So Sedona has been using this library called GeoTools to process raster dataset. So the GeoTools dependencies has been upgraded to the GeoTools community has updated GeoTools to Java 11. That means in the past release of Sedona, we were not able to use the latest version of GeoTools. So that leaves us lots of bugs and security problems. And on the other hand, lots GeoTools as a very old project, lots of pieces in this project were not well maintained, especially when it comes to some uncommon raster operations. So there's another project called Apache SIS that provides really good support for raster data processing. We really want to integrate with Apache SIS. However, Apache SIS is also a Java 11 library, so that means we have to upgrade to Java 11. And on the other hand, so GeoTools and Apache SIS unfortunately have a namespace conflicts. So due to their long history, right? So by upgrading to Java 11 and using the latest version of GeoTools and Apache SIS, that allows us to have both projects as dependency of Sedona and also address the namespace conflicts. Uh, Another thing is as I mentioned, so the GeoTools dependency has security issues, right? So that actually prevents us from releasing the latest version of Sedona Snow. Sedona Snow, as I mentioned before, so it is a free app in Snowflake Marketplace that provides geospatial support of Sedona to Snowflake. So this extension relies on GeoTools, but GeoTools, as you know, the old release has security problem, but since it is a Java 8 library, we were not able to fix the security release and hence cannot make a new release of Sedona Snow. All right. So I would expect the Java 11 support has a minimal impact on the community. So this is because, as you see here, all major Spark hosting services have at least one LTS, long-term support version on Java 11. So Databricks runtime just released 16.4, so that is Java 17. And AWS Glue is using Java 17. EMR has Java 17 version, and the Microsoft Fabric has been using Java 11 for a very long time. And the Google Data Product Spark is also used Java 11 from the very beginning. And the Snowflake Java has been using Java 11 as well for a very long time. And Flink 2.0, which has been released couple months back, now defaults to Java 11. And of course, the next release of Spark 4.0, is actually also defaults to Java 11. So that means, right, I don't think the ecosystem is pretty much ready. I don't think this will have a major disruption, interruption on the Sedona community. But if you think there is any issues with the Java 11 support, feel free to create issues and comment on our GitHub, right? And we also have Discord channel, so make sure you also speak up there. So here is a quick example about our PyFlink support in the upcoming release. So the PyFlink support after you install the Python binding on Sedona, so you can easily create a Sedona context like this one. Basically, it asks for the Flink streaming environment variable, and after that, you can put a spatial SQL query here, like what you did in Java and SQL. You can use starea and stgem from WKB, like this way. All right. So that is about the update of past Sedona release and upcoming release. So now I'm gonna spend a little bit time to talk about uh, GeoParquet, Iceberg geotypes, and the Parquet geotypes. So this was part of my presentation about the Iceberg geotype launch live stream last month. So I took the content from there, right? So just in case you guys haven't heard of it, I'm gonna talk a little bit about this topic since these are very hot topics. Everybody is discussing that, and also there are some confusions around. So what is GeoParquet? What is Parquet geotypes? And what is Iceberg geotypes, right? So I'm going to spend probably 10 to 15 minutes to talk about those concepts. So first of all, what is GeoParquet? Sedona has been the very first GeoParquet GeoParquet reader and writer, starting from a couple years back. So GeoParquet, in short, it is a community effort started in 2022, and it is a cloud-native data lake format built on top of Parquet. So what it does is it defines how you should encode geospatial data in the Parquet format. It also defines how you put spatial statistics, that means bounding box, as well as data type in the Parquet file. So that way, based on the standard, you can easily share spatial data through the Parquet, but also follow the standard, everybody is able to read your data. So GeoParquet is a very popular project, and many tools have been supporting GeoParquet for a while, including GeoPandas Apache Sedona, of course, and Google BigQuery as well. And also many spatial data set vendors started to use GeoParquet. So a very good example is actually from Overture. Many of you probably have been using Overture data, right? So Overture data uh, uh, is all released in GeoParquet format, and the Overture is using Sedona to generate all their Overture dataset in GeoParquet format. So Overture is a big user of Apache Sedona. So what is Iceberg? So that is GeoParquet, right? So what is the relationship between Parquet and Iceberg? What's the difference? So first of all, so Iceberg is an open storage format for data lakehouse, right? So data lakehouse is a new technology started a couple years back. So that is to revolutionize the old traditional data warehouse technology, right? So the key point of a data lakehouse is you need to have compute and storage decoupled from each other, and the storage layer must be built on top of a open table format or open storage format. So there are many options out there, including Iceberg, Delta Lake, and Hoodie. So among these formats, so Iceberg is the most popular open storage format, right? So here is an example about a single Iceberg table. So as you can see here, there's a couple things involved in an Iceberg table. So first of all is the data layer. So that includes a bunch of data files. And the second thing is the metadata layer. So that includes lots of metadata. Metadata describes what the data is and how you should look up data. And the third thing is the catalog, right? So among three things here, so the metadata layer and the data layer both state on the S3 bucket, on the same S3 bucket even. And the Parquet file, the data file here use the Parquet format. So that's the relationship here. So basically, Iceberg use Parquet format as the storage format or storage standard in the data file. So you store data here, in the Parquet format, but it adds lots of metadata layer to manage those data file. And of course, there's a catalog layer. So the catalog layer is usually is a data service running all the time, and it is usually built on top of like a OLTP database to manage different to coordinate between different readers and writers. All right. So what is Iceberg GeoData types? You probably have seen this like seen this news many times in the past few months, right? So this was a really big announcement. So Iceberg GeoData types is an effort among multiple companies in the community. So basically, in around late 2023, so we're about to started this project called Havasu. It is a production-ready Iceberg fork that equips with geospatial data support. And we have customer use it and they enjoy that. And after a couple months, in early 2024, so there are a couple community members in the Iceberg and the Geo community start to discuss. So why not we bring the geospatial support into Iceberg so that the table format could understand geo data type natively. So that means you have better standard, you have better statistics, and also better performance. So there are multiple companies involved in the process, including Variables, Apple, Planet, Carto, Snowflake, BigQuery, and Databricks. So after a year-long discussion, in February 2025, Iceberg GeoData type merged into the Iceberg v3 spec. So this is just the beginning. So Iceberg, as you know, it is open table format. It comes with two things. So the very first thing is we call the spec or the standard. So the standard of spec defines how you should encode and store your data in Iceberg table, and it defines every single piece of Iceberg table. So that's a standard of specification. So in order to actually enable users to read and write geospatial data in Iceberg, you need to have implementation. So in February this year, we merged the geo support into the Iceberg standard, and now we are working on the implementation of the Iceberg geo data type. So we already have implementation from released by Variables in Havasu format, in the Havasu fork. So we are actually working with the community to bring those implementation to the official Iceberg repository. So there are a couple PRs going on right now on the Iceberg reader and writer GitHub repository. So if you're interested, you can find this on GitHub, right? So once those PR merge, so you'll be able to immediately manage your geospatial data using Iceberg table. But before that, you can still do it using Sedona with Iceberg, but the way you do it is a little bit hacky. You need to use WKB as an encoding method to work with the geo data type there, and some cases you don't have really good filter pushdown performance. All right, so let's dive a little bit deeper and see what was actually introduced in the Iceberg geo data type. So actually, when we talk about the Iceberg geo data types, we actually talked about two things. We actually introduced two data types altogether in this PR. So the first thing is we call geometry data type. The second thing is we call geography data type. So these two data types are basically borrowing the concept from PostGIS. So as you know, if you use PostGIS before in the PostGIS ecosystem, it also has two data types, geometry and geography. The only difference, or the major difference, is so the geometry data type assume the line between 2 points a straight line, right? So it always assumes the data operates on the Cartesian plane, right? And the geography data type assume the line between 2 points is always is a curve, right? Always assume you're using spherical edge. So that's the major difference here. So the same difference also exists in the Iceberg geo data type. So basically, in the two data type, it has a property called edge algorithm that actually defines the type of the edge of each object. So in the geometry type, it is straight line, and in the geography data type, the edge algorithm is spherical edge. Another thing is the CRS. As you know, CRS is always a topic that everybody has different opinion on. So in geometry data type, you can use any CRS as you want, and we allow two types of formats of the CRS. One is Project JSON, and another one is SRID, right? So in the geography data type, it also allows two CRS formats, Project JSON and SRID. However, it applies one more restriction on those CRS because the geography data type is one that is used for spherical edges. It only makes sense when you use geographic CRS. So that means the CRS here must be a geography CRS. It cannot be a projected CRS. And it also has a restriction on the bounds. Again, because we're assuming we're using the spherical edge and we're operating on the geography CRS. That means it only makes sense if you use the longitude and latitude that is in the 4326. That means the longitude has to be between -180 and +180, and the latitude must be within -90 and -90 and +90. So that's the restriction. So yeah, so this is basically what we introduced in the Iceberg geodata types. And another topic I want to talk about is the Parquet Geo types, right? So you already saw the GeoParquet format. You saw the Iceberg geodata type. So what the hell is the Parquet Geo type? So Parquet Geo type or Parquet native geotype is a byproduct of our Iceberg geodata type effort. So basically what it does is it introduced the native geotype standard, the geometry geography data type I talked about, into the Parquet standard and make it a native data type instead of a separate data type defined in a community standard. So eventually, the GeoParquet community will use the Parquet native geotype to replace the old GeoParquet standard. So in other words, we are working on something called GeoParquet 2.0. So GeoParquet 2.0 going to be using the native Parquet geodata type to store data. And we're going to provide you with a guidance about how you're going to migrate your current GeoParquet format or dataset to the native GeoParquet 2.0 and native Parquet Geo data types. And by the way, so there are some really good benefits of using the native Parquet Geo data types. So the most important thing is you are able to have granular statistics, meaning that because this is native data type, you can actually have even granular statistics. You can have row group level bounding box statistics that gives you even better data skipping performance. And of course, we also introduced the geography data type support that allows you to store geography data, meaning that data with spherical edges in the Parquet Geo tab. All right, so that's basically what I want to talk about today. As you know, Sedona is always call for help. So in our Sedona GitHub repository, so we have lots of notebook examples, right? So if you find any bugs there, and or if you want to add new examples, you're always free to create a PR to contribute back to Sedona. And if you find some issues with our documentation website, or if you want to add something to the documentation website, feel free to create a PR. You're also more than welcome to participate in our release test, right? So before we make each release, we actually have a voting process on our mailing list so that you can test and verify the release before we actually publish it. All right, so I want to take a pause here and see if there is any questions from the audience. So if you have any questions, feel free to raise your hand. I'm gonna allow you to speak. You can also, by the way, post any question you have in the chat. Okay. There is a really good question from the audience. So does Iceberg use regular Parquet or GeoParquet? Good question. So as I mentioned, so the Parquet native geotype is a byproduct of our Iceberg geotype, right? So this is actually because Parquet wants to use the native, sorry, Iceberg wants to use the Parquet native geodata type as the storage layer of the data file. So as you see here, when I say Iceberg geodata type, so it actually uses the Parquet native geotype here as a storage layer instead of GeoParquet. So that's why when we release the Iceberg geotype, we have to also make another change to the Parquet standard to add a native geotype support. So that's why it is a byproduct of the Iceberg geo data type effort. Cool. Any other question, folks? Feel free to ask any question, or if you want to speak, just raise your hand. If you have questions related to the past release and the new release, and have questions regarding how to use Sedona. Okay. Cool. Okay, a couple questions. So the first question is, are there any other file format which are efficient to store geodata? Good question. So I would say, so Parquet. So Parquet is a really good one. So, other formats. So first of all, I would suggest that do not use shapefile, right? So shapefile, as you know, people, although lots of people use it, but lots of people actually hate it. The problem with shapefile is you have lots of this kind of sidecar files together with the data file, right? Another one is don't use GeoJSON, which is not efficient. And even if you just have a very small amount of data, it's going to explode your storage if you use GeoJSON. So I would say Parquet is one. Another one I would say, uh, I think GeoPackage or GeoDatabase probably are compressed in terms of storage. The storage efficient, right? But the problem with those spatial format is only the geospatial tools understand it. No other tools understand that, right? So I would suggest that you sort it in a format that all other non-spatial tools that can also understand it. So from that regard, I guess in addition to Parquet or GeoParquet, I think ORC is another one. Although, uh, by the way, ORC recently also introduced the geodata type support as part of the Iceberg geotype effort, because Iceberg also has an option to use ORC file as the storage layer of the Iceberg table. So that is also why ORC project also added geospatial support. So you might want to consider ORC as well, right? Okay. Mm, okay. Another question. So is there any plan to include other format like ZAR? So that's a good question. We do have plan to support ZAR, and it is coming up soon. So I think right now, uh, we support GeoTIFF, right? So that is already widely used in many REST releases, including Stack. So we're going to continue to support GeoTIFF. For that, the main problem is that our REST dependencies right now is a little bit mess. So we want, as I mentioned before, we want to in the next few weeks, we want to clean up the REST dependency, the GeoTools dependency, and the Apache SIS dependency. We want to fix those, and that will give us opportunity to support format like ZAR. Okay. And another good thing about Sedona is by supporting ZAR or GeoTIFF, this kind of raster format, you will be able to join raster data and vector data together in the same engine. So this is a capability that is you can really find elsewhere. Okay. Okay, there is another question. So is there any training manual for Apache Sedona? Yes, there is. So we actually released a Sedona O'Reilly book, and it is for free. We actually released Sedona O'Reilly book that actually talks about how you can work with Sedona and many and many internal concepts of the Sedona release of the Sedona project. So let me actually send the link in the chat. So I actually typed a link in the chat. So that links take you to this web page that allows you to download the O'Reilly book of Apache Sedona. So it is still early release, meaning that we are still working on the book right now. We have finished I would say 70 or 80% of the book, right? So if you're interested, please feel free to download download the book there. It is free and it has a code example. It has lots of concepts talk about what is raster data, how to do raster data, vector data, spatial join, right, in Sedona. So if you're interested, be sure to download the O'Reilly book there. Okay. So the link to the book in the chat. Okay, folks, be sure to download the book there. Any other question, folks? Okay, another question. So what about more complex spatial analysis like networks? Good question. Right now, I would say uh, we don't have direct support for the neural network, but I think that is something we want to really want to support. But for example, right, so I mentioned that in Sedona, we recently introduced the OSM PBF data reader. So that is actually neural network data reader. So the data frame you read in Sedona, that is actually two tables that can actually compose a neural network, like a node table and a weight table. Essentially, that is a neural network vertices and edges. However, in addition to the neural network dataset itself, right, our data reader itself, I love to see some customer requests about what exactly neural network analysis you want to support in Sedona. Like, do you want to do shortest path or do you want to do like isochrons? So what are the spatial analysis on the networks you want to support? I think the community would love to learn that, and I think based on that, we can decide what kind of features we want to support over the road networks. But that's definitely something we want to support. We envision Sedona to be a comprehensive spatial computing engine. So road network analysis is part of that. All right. All right, guys. Any other question? Okay, guys. Uh, one last thing before you go. So as you know, so we always welcome some success story of Sedona. So if you have any success story about you Sedona in your work or in your life in general, right? Feel free to reach out to me, and we'd love to have you talk in our live streams, including the community office hour, including separate live stream to talk about those use cases. And I think the community would appreciate that, and your story will help them better understand what they could do with their data. How could they make sense of data and find the values of the geospatial data? So if you're interested in sharing your success story about using Sedona, feel free to reach out to me. And you know my Apache email is jiayu@apache.org. We also have a Discord channel. So please be sure to join our Discord channel and you can find me there. Okay. All right. So thanks everybody for attending the community office hour today. So if you have no other questions, we can stop here. Thank you for joining me today. See you next month. Bye, guys.